Hello everybody, and what is up? Another week of CS 202. This week we are covering templates. It's the last of the topics, I think, and then we will be done with the C++ language. And then for the rest of the course, we're going to be learning about other things, such as recursion and some data structures like linked lists and stacks and queues. So it's pretty exciting. Maybe we'll finish today. If not, then we shall finish on Wednesday. So let us begin. So, as I said today, we are covering templates. Now, there are two main kinds of templates out there. There's function templates and there's class templates, as it says right there. Basically, they both do the same thing, there's just some peculiarities that are good to know between them. But first, let us kind of understand what templates are and what they can do for us. So, templates are by no means something that is required to code when you're trying to achieve something. In fact, I would say that pretty much none of the things that you're learning in 202 like are mission critical. I mean, you really, if to run a program, all you really need is like an if statement, some sort of loop, and some variables, and you're good to go. Everything else is bonus. But this is one of those bonuses that make your life a lot easier. And they really lined up with the whole talk about polymorphism. So let's kind of refresh what polymorphism is. So polymorphism, as the name implies, poly being many and morph being shapes, it means many shapes, right? And what it means in C++ is the ability for a line of code, essentially, to be able to achieve different things depending on what it was based on. An example of this is, for example, function overloading. Function overloading allows you to call a function, say print, and pass it different kinds of parameters, and it's still going to, no matter what, print things out, because as the name implies, it's print, right? On the other hand, when you get something like operator overloading, it allows you to use something like a plus b, and you don't have to worry about how that is implemented or how that works. You know that a plus b is going to give you the result of that addition or concatenation or whatever you want it to be, even if it's custom data types, because then you can overload the operators, right? So that's another of the things that you typically associate with polymorphism. And those are compile time polymorphisms. But runtime polymorphism we saw with virtual functions, right? With virtual functions, we have a superclass, and then you have derived classes of that have the shared common parent class. And then from there, each of these functions can potentially extend the functionality that is shared among them, such as, again, going back to the same example, print. So, no matter what kind of object it is, you know that if you call the print function in it, you're going to get some sort of printing happening. And that's the beauty of polymorphism. You don't need to know the internals. You just know that any object in this code, because they all have a parent class that's shared, has a print function, and no matter what kind of object it is, what kind of variables it has, you know that if you call print, it's going to print whatever is in there, and that is all you have to worry about. And that's the power of polymorphism that makes our life much, much easier when we're coding. We can just call print and it'll do it. And of course, I'm giving you as an example print, but it can be any other thing, such as any operators or any sort of generic things. I was talking about exception handling last time. With exception handling, you can actually, there's a shared function between all exceptions that's called what, and what is a string function that returns a description of the error. So there you go. You know that if you generate an exception, even if you don't know what kind of exception it is, if you call the what function, which is literally like what, then it will return to you a description of it. And that is power polymorphism. Now, virtual functions is runtime polymorphism and operator overloading, and function overriding and overloading, and those things are all compile time polymorphisms. Templates is going to also be compile time polymorphism, as far as I'm concerned. Yeah, I think it's considered compile time. So yeah, it's pretty cool. And let me go ahead and show you what we will be able to achieve if we learn this power. So, I guess, do I need to draw anything? Actually, before I write, let me give you the premise. Yeah, I'll give you the premise of this. So, suppose that I wanted to create a function that added two things together. One way I could do that, well, of course, I can overload the plus operator and make my life easier. But suppose that I don't wish to do that just yet. Maybe I just want to have a function called add. And this function, actually, maybe it returns a type. Let's say, you know, we have two integers. So we got integer A and integer B. And of course, we are going to return A plus B. You know, if you wanted to do this in 2 lines, you could say something like int answer. Actually, you could do it in 3 lines, I suppose. And answer is equal to A plus B, and then return answer. Now, of course, again, you could do this in 1 line, but maybe I'll leave it like this for a reason later on that you'll see. Okay. And so, of course, we know that we can go ahead and call the function add, and we can say 5 plus 3, right? And then, of course, if we see out this, we should get the value of 8 if we did our mathematics correctly. Well, we got an error. What is the actual error? I gotta actually read the error. Too few arguments. Oh, well, whoops, that's not what I meant to do. Comma 3, because I'm passing this parameters, right? So anyways, if we go ahead and run that, then we can see right here is the 8. Just kind of hidden there, but it's there. In fact, maybe we'll add an end line, okay? But here's the thing. This function, you know, if I try to pass it like, let's say 2 floats, or yeah, let's do 2 floats. So we do like 3.4 float. I keep wanting to do the plus. And then we pass it like 2.6 float. You know, we would expect this to give us 6, right? If it was accurate. However, we're not going to get 6 from this. We're actually going to get 5, as you can see right here. And the reason for that is because of coercion, right? So what is happening is there is no add function that has to float parameters. And so the only one that we have is this one. And so these get coerced into a integer, each of them. So this gets 3.4 becomes a 3 and 2.6 becomes a 2. So essentially you're getting 3 plus 2. And that is why you are getting back a 5. Sorry, 3 plus 5. But even by the way, even if these were actually floats, the fact that we made the answer an integer means that it would actually, well, in that case, if these were floats and the addition happened correctly, then because this would be equal to 6, then we would actually do get a 6 once it gets coerced as a return value. And so the solution that we know for this is, of course, to overload this function, right? We can overload it by taking this function and then essentially changing these to be floats. And like what I was saying, technically speaking, this will actually work still, even though we are returning an integer. I don't know how that happened, typos. Here we go. This will work. Come on, express primary expression. Oh, I thought I deleted that comma. I guess I just wrote extra. Okay, wow, we should be good. There we go. So as you can see here, we do get a 6, right? Although technically speaking, that's kind of dangerous because, you know, if this was 2.7, then we should be getting 6.1, but we're still going to get 6 out of that. And so that is because the return type is still an integer, right? So what we can do is we could actually change this to a float if we wanted to. But anyways, the point is that you have to handle every different type by hand, making their own functions. It could even get worse than this, because suppose we had one where we are passing, well, you know that if we are passing 2 objects that we haven't overloaded the plus operator, this would not work at all, like flat out. So like if we try to pass in, like, let's say we passed in, let's say we can make a class A, and there's an index in this class A. We can even make it public. And if we went ahead and say something like A1, A2, this just flat out will not work because A, there's no function like that, and B, the plus operator is not even there. So yeah, we're gonna get like 50 billion different errors, as you can see there. Okay, it says there's no known conversion from A to float or A to integer, which means that neither of these functions work as is. And even if we went ahead and created such a function, you know, we said, okay, we're gonna allow objects of A to be passed in, we are now just going to get an error with the plus operator because it says we need to overload the plus operator, right? Did I save it? No matching candidates. Why no matching candidates? There should be matching candidates. Oh, I see why. Because we need to move the class declaration above the function call so that it doesn't get confused when it sees it. Otherwise, it's like, what is this A you're referring to here? There we go. Now we're getting the error that I wanted to get here. Just have to scroll up to show you that it says that no match for operator plus, which is essentially saying that you need to overload this because it doesn't know how to handle that. So, of course, we could go ahead and do that and then actually get this to work. So I'm going to go ahead and do that now because it'll come in useful later. And it's also a good review for your operator overloading. So we're going to make it a member function because why not? So it's going to be return. What is it going to return? Let's just say it returns an integer for now. Because then we have to overload the C out otherwise. So, or actually no, let's return an A. Yeah, why not? So it's operator plus, and then it's going to take a const A colon R for the right side. And essentially this is going to return X plus R dot X, like that. Yeah, okay, but we're gonna make it all one line again because we are already running out of space. Okay, so can I convert A operator? Can I convert blah blah blah? Okay, that is fine. And now, because we haven't overloaded this, just to show you that it works, I'm going to cheat and mess around with the type using reinterpret cast. I think it would work with static cast, but we'll use reinterpret cast. We'll make it into an integer. Yes, the forbidden cast indeed. Okay, so expect. Okay, so I just need a semicolon. Wait, I never had that semicolon before. How was this even working? I guess it was. Well, never did because we never compiled it. But yeah, okay. Can I convert this A into RAX from int to A? X plus. Maybe it needs a parentheses. Because we are passing by reference and it's not a pointer, so it shouldn't need anything fancy. Why is it not liking it? X is referring to the left side, which it doesn't need this thing. I mean, I can add it in, but it shouldn't make a difference. And then this is not a pointer, so it should have its own X. So I'm not sure as to the why. Could not convert this A in plus in from int to A. Oh, I see what's happening here. This is an integer, but we wanted to return an object of A. And so, yes, you're right. Yep. So, yeah, it's because we were getting ahead of ourselves. So here, let's just make an object called A, and then let's go ahead and return. Well, and then let's go ahead and add them together in there, so we can say that A dot X is equal to X plus RX, and I really don't think we need this parentheses now. And then we can return A. Okay, so we should be good now, at least for that part. Okay, expected. Okay, semicolon. All right, and now finally, can I convert A into int into the assignment? Why did you want to convert it into that? Oh, because here it's an integer. So here let's go ahead and switch this over to an A type so that it returns an A type. Okay. All right, now we can just worry about casting this part. So for this cast, how we're going to achieve this is we are going to get the address of that, and then cast that into an int pointer, and then maybe dereference that. I think we'll get around that this way. Taking that as a temporary. Yeah, sure. I know it's temporary, but whatever. Failed. Okay, we may have to. How do I? I know the error I'm getting is that this is not. It's just a value that I'm getting back from this function, which represents the a, but it's and it's saying that it's going to disappear immediately after, which is why I'm doing it for permissive. But by the time I'm already getting it back, it's apparently garbage. Or actually, what it is there, maybe it is working, but I just need to give some values to x. So maybe we'll do that. So a1x gets through 2, and then a2x gets 4. Let's try like that. There we go. We get 6 now. So it worked. Albeit not kindly, but it worked. Okay? On the homework, I was having trouble with returning the class because it would call the constructor. Returning the class because it would call the constructor. You mean it would call the destructor? Maybe that's it, because when it goes out of scope, it calls the destructor any dynamic objects that you've made. Actually, any object that you've made in the class, in the function. So that could be it. Or actually, maybe what you're saying is the return. No, because when I say return here, it's returning this object which has already been constructed. So I think you mean destructor. Otherwise here, I don't think that temporary would be that constructor you're talking about. But yeah, anyways, it works. We get a 6, and I can make this a different number just so you can see. This time we should get a 10, as you can see. Okay, I know we wouldn't want to do this. We would instead want to overload the what is that? I'm gonna get them wrong again with the cout operator. This is the stream here. Let me go back up. Stream insertion operator. Yeah, stream insertion operator. That just feels backwards. I really think that's backwards. I don't know. Even though we saw it from the book, it just does not feel right. It feels like it should be the extraction operator. But yeah, okay. Anyways, so as you can see, we have to handle every single case by hand. And if we want to add one more, then we still got to handle it. In fact, even ones that would work otherwise, like suppose that we wanted to pass in 2 strings, right? That will not work in any of these. You have to actually make another function, because like if I pass 2 doubles, that's fine. They'll get put in the float one or in the int one. I'm assuming it will get put in the float one, but that'll be good to go, right? So you don't need to include all types. Some of them you can let it course and it'll do okay. If you pass this to cars, it's probably going to go into the int one. But if you pass it to strings, that's where it's going to get confused. You got to make a string one. And so what we want to achieve with templates, and we will achieve with templates, is we're going to make some sort of generic function that will apply for everything. We're going to say, here's this function, here's the first variable on the parameters, here's the second variable on the parameters, and I want you to just plus these things together. I don't care what they are, doesn't matter what they are, just try that. And as long as you've overloaded the plus operator, it'll work. And that's what templates are. So before I show you, let me write to you the syntax of how templates go. So let's talk about function templates first. And that's because class templates will kind of go directly there. And so again, the goal is we want to be able to have one function that we code, a single function that we're going to code, work for any data type that we pass it in. It's a template variable, essentially, which will get populated once we actually know at compile time what that type of variable is. So suppose that we wanted to do something very simple, which would be just like a function that does nothing. There's no body to the function. It's just a function that takes one variable of any type. Well, let's go ahead and first write it as if it was an int function. So let's just say, actually, let's just make it a void function. Start with something very basic. A void function called foo. Of course, we need to have a one parameter because otherwise it doesn't matter. So let's say we're going to call it int t. And that's our function right there. Just that. Okay? Thing is, if I want this function to work for any data type here, I'd have to create pretty much like infinite amount of functions here if I have an infinite amount of data types, like classes, right? Otherwise, if I wanted to work for like, this would work for most cases of like built-in data types, except for like strings. That one wouldn't really work. So even for built-in data types, I have to write multiple functions. Well, what I'm going to do is I'm going to replace this right here. You know, I'm also going to change the variable name. I really shouldn't use that. I should use like an A or something. So like int A. And I'm going to replace the word int actually with a T. That T is going to represent some data type that is unknown. It's a template. That's why I put a T. It doesn't have to be a T. It could be any variable, but I just put T there. Okay? And so that type is going to get filled in when the function gets called. Because when the function gets called, then I'll know what the data type is, because I can see it in the function call. And I know all function calls ahead of time because of the way C++ is set up. I can easily populate that function. You know, I can populate that function call with the right variables at compile time. So templates allow you to achieve this at compile time. It cannot be at runtime, otherwise this won't work. So now I have to write some fancy syntax to get this going. And so I have to write the word template. Then I have to write the less than sign, the word class, the name of the variable that you want the template to sort of represent, and then a greater than sign, or whatever you call these. There is another way you can do this, by the way. You can also, instead of putting class T, you can put the word type name and then T. So that's sort of the alternative. Okay. There is a slight difference, but for our purposes, you can assume them to be the same. But I would recommend you use class T. Okay? So that's pretty much it in terms of syntax. So again, what is happening here? What is happening here is that when we see in main somebody say like foo5 or like foo high or foo a, assuming that a is some class, whatever, what is going to happen is it's going to go ahead and look at this function, and it's going to change the T, which is a templated variable, with the data type that these functions are being called with. So for example, here it's an integer, here it's a string, or an array of cars, maybe, I'm not sure. And then this one here is some class A. You know, assuming that it's the code that we wrote earlier, right? But it could be whatever. So whatever the type of that is what's going to get populated there. And it's going to kind of like on the fly generate that function. Now this function isn't really doing anything. It's just kind of like, it just happens. But of course I could put some code in here and it'll basically handle it. So like I could put something in the function that says cout A. And then A, you know, as long as the cout works with that, and by that again we're talking about the stream insertion operator, as long as that works and you don't need to overload it, then it'll work. If you do need to overload it, then go ahead and overload it and then it'll still work. But you're only writing one single function for this thing instead of having to write 50 different functions. So let us go ahead and look at that with the code that we have so far. So we have this add function, right? Let us go ahead and make a templated version of that so that we can just throw away literally all of this stuff, well, with the exception of the class. It's like an addition function. Do you use it? Do you use if statements to find what type of data type it is, then do the addition? You don't have to. In fact, you don't want to. I mean, you could. I think there's a way in C++ with libraries that you can find the type of variable. I think we've done that at some point in the summer. But you don't have to, because all we care is just doing the plussing. And as long as we know that that plus will work with that data type, then we're good. And if not, then, you know, make it a general practice to overload that operator if you're going to be throwing it into a templated function, just to make sure it still works. So just wait and see here. Let's see. So I will eventually delete this stuff because we don't really, in fact, let me go ahead and delete like one of them. We'll delete the float one just so we have some space. Okay, and then let me go ahead and make a templated version of this function. So template T, and again, our template class T, And again, this is just a variable. I could call this potato. I could call it any variable name would work there. But T is kind of like the thing that people use because I guess the word template starts with a T, so they kind of stuck with that. But I mean, if you can have, as you'll see here, you can have multiple templated variables. Because like the next thing I'm going to show you is what if these two are a different data type. Because so far we've done like int, float, class A. But what if you wanted to do like int and float? So I'll show you that too. But first, again, we start with a simple one. And then I guess for now, well, I said void in the example, but you know, what we really want to do is we want to return something, right? And let's just say we want to return the same type that the parameter is. So that type is represented by the T. That T can be an integer, a float, a double, a string, a class A, whatever. And we call it, instead of foo, we're going to call it add. And then we have the two parameters. Normally, those parameters would be like int, float, whatever. In this case, they are going to be of that template type. And then just give them some variable names, which we'll use A and B as we had before. Okay? And then in here, again, I could do this in a single line. I could just say return A plus B, but I'm going to do it in 3 lines so that you can kind of see what's happening. Okay, so we get, first we make an answer variable. Then we're going to say answer gets A plus B, and then we're going to return answer. Okay? And actually, I'm kind of curious if this will compile as it is now because we have these custom ones already. So it might be like angry at that. It did. Okay, cool. So it's cool that it actually is okay with that. Let us fix this nastiness by actually really quickly overloading that operator. So OS stream. I don't remember if that one needs this. I think that's the IS stream that needs that. We'll see if it compiles. Operator and OS stream ampersand out. And then, oh, this one has to be a friend function actually. Because we don't have a way of putting it there. So yeah, so then we got A as a const. And then all it is just basically out of A.x. Okay. That's the one I couldn't remember if that one needs it. Because I think it's the IS stream and the OS stream. One of them needs it and one of them doesn't. So I guess I'll put it if you think. I can't remember which one it is off the top of my head. I probably did not make them match perfectly. Const ampersand. No, so maybe I was right. You don't need them. I don't know. Friend used outside of class. Well, yes, friend is used outside of class. But I don't need the word friend there. That's what the error is telling me. Okay, so it's good. So now we can get rid of this nastiness and go back to some sanity like that. Okay? So we don't need the ampersand, I suppose. I guess that one is for the IO stream, I suppose. But we'll see. Let's see if it actually prints out. In fact, before we use our fancy template, just to make sure that the overloading worked, let me comment that out and just run the code. For now, the float's going to get used with the integer because we deleted the float function, but that's okay. Segmentation fault. Okay, so maybe we do need the ampersand. Let's try to bring him back in. There we go. Cool. All right, so we get that 10, so that's good. All right, so now we're going to go ahead and put in the template. And as you can see, we get still the same thing. However, let us go ahead and comment out this function here and this function here. So all we have left is just a templated function. One function, can we achieve the same results? As you can see, yes, we can. So here you're looking at a templated function that is able to handle any data type that you give it where the plus operator works with it. In fact, let's even throw in strings now. hello world, maybe with a space here so that it actually prints out with a space. We gotta run this. Invalid operands. It does not like them? Why? Constant car, constant car. Okay, let me cast this to a string. See, that's what I was talking about when I said the array of cars. That's this. So, yes. This was just a static cast. When you go ahead, in C++, when you say something like A equals and you just put the quotes in text, that's technically not a string. It's an array of cars and it's constant because you're hard coding it. And so that's kind of what, normally it just gets coerced into a string. But when you're doing things like this, it's not. So you're gonna have to force it into a string. So here we go, hello world, okay? So now why doesn't it work with the two constant arrays? Because you're trying to add two arrays together, which we've established in 135 is not a good idea. However, we could probably overload the, we could overload that operator. Could we though? Because it's built in. So I'm not sure, but if we were able to, we would just have to kind of do some weird for loop that does nasty things. So, but I'm not sure because again, operator overloading, you can't overload like operators that are already built in, but I think that wouldn't let us. I'm not sure. Might. You can only find out if you experiment. But anyways, the point is that now that there's strings, this worked out fine. So as you can see, it works for every single case. Now, it won't work for cases like, again, if we get rid of this overload of the plus operator for this class, then we will get confused because it's like, okay, yeah, I'm using the templates and everything, but I am at the end of the day going to end up with A plus B in the case where they are of class A, and I don't know how to deal with that. So this, of course, is where operator overloading actually comes in useful. So you can prepare ahead of time for these kind of situations, right? And so, you know, that's pretty much all there's to it with templates. It allows you to save time writing the same code, you know, 50,000 times, you know, and that's very important because other than saving you time creating the code, it saves you time updating or maintaining the code. Suppose that you decided that you don't want to just add A plus B. Maybe you want to add A plus B, but like for some reason you want to do B plus A, or you want to also add some other math in here. You can add it here and it'll affect every single one of them, right? And that's the beauty of the templates. As you saw, it compiles also with this code in here. So the cool thing about that is that, let me go ahead and re-uncomment this code, but for some reason, I'm just going to go ahead and make that a subtraction, okay? And run this code again. Yeah, okay. So go ahead and look at what happened here. So we went ahead and got a 2 now. And before, let me switch this back to a plus. Run this again. Before we were getting an 8. 5 plus 3 is 8. 5 minus 3 is 2. So the beauty about templates is that you can use them to cover everything. But suppose you have that one exception that, like, for some reason with integers, you actually want to do a subtraction with a function called add. Don't ask me why, but I'm sure that's going to show up at some point where you need to do an exception to a template function. You might be like, oh snap, because of that one exception, I can't use templates. No, you're fine. Templates will work for every single case. But if you want to have special cases, you can actually code those in, that special case with those special set of parameters, and then do that own variation. And it will prioritize the exact match before it goes to the template. So you can use that to basically, you know, modify functionality for the special cases. Templates seem way less painful than I expected them to be. They always look very arcane when documentation would mention them. Yes, because they are very painful to work with, actually. This looks cool because we're dealing with function templates. We're gonna now talk about class templates, which again will look very simple. I mean, that's the whole point of me teaching you stuff, is to make it look simple. But here's the problem where this will get nasty. When you start doing inheritance and you start doing like a template inside a template, like template inception, that's when things get a little nasty and people kind of lure away. I was writing a template class last week in 302 for like a tree, and already there I was like, I regret using templates. So doesn't matter what that special case is. Like the templates have to go above the exceptions. I don't think it matters, but let's just test it very fast. Because like it doesn't matter how you put these normal ones. It only really matters like because they're just looking for a function in like a table of functions. So as you can see there, it did not matter indeed. So yep, we're good. So yeah. So templates are cool, but they can get a little nasty when you're dealing with like complicated code that has multiple inheritance and other nasty stuff. But that then again is more of the problem with inheritance than it would be really with templates. Okay, before I show you class templates, let me go ahead and show you how to do a function that has two templates. So suppose that we want to overload now the what do we want to, well, not overload. Let's see what we want to do. What would be a cool thing? That takes two things. Can't think of anything, so we're just gonna do multiplication, I guess. Actually, oh, okay, why not? Sure, multiplication will be interesting. So suppose that you wanted to do, well, first let me write you a normal function. Suppose you wanted to do something like int mult for multiply, and then you want on the left side, it's weird, an integer, and on the right side maybe you wanted a float or a different variable, a different class. Okay, they're never gonna match. For some reason you want them to be different, and then the result is basically a multiplication. Okay, so you return A times B. Again, there's probably better usages of this, but I'm just kind of giving you an example where they have to be different types. Okay, if you use a template thing, it's not gonna work. It's gonna get confused because it's expecting, they're both here T, so it's expecting the same data type for both. So like two integers, two class A's, two strings, everything is fine as long as they're the same type. But the moment you throw in different types is where it gets confused. Okay, actually, you know, let me do add. Let me go back to the add, but say that I want different types. Yeah, that's actually, that makes more logical sense. You know, because right now, if I do something like this, A times B, and I try to pass it like a string and an int, it's going to like get confused and everything, right? Well, I will always get confused with a string and an int, but you get the idea that you might not always want to give the same types. Return is the best return type. So yes. So yes, I didn't even notice that. But yeah, okay. So yeah. All right. So let's make this templated and see how that would work. So for that, you're gonna again write the word template, and then because we have two templates, typically I've seen people use the word U and T. So I'll go ahead and do that. And the way you do them is, and this I guess is the first thing you gotta be careful is, you can't just say class U comma T. You have to say the word class multiple times, like class U comma class T. Think back to like when we were doing multiple inheritance, you know, if we had like a class X that was inheriting from two classes, you know, and you did something like A comma B, this works fine. They're both inherited privately, but then you're like, oh yeah, let me make one public, like that. And then you're like, oh, it's gonna make A and B public. No. It's only going to make A public. If you want to make B public too and inherit publicly, then you have to write public twice, right? So remember that when we're doing multiple inheritance, it's kind of the same idea here that you have to put the word class for every single one of them. So that's the first thing, I guess, that you have to be careful about. But that one is easy because if you don't do it, it'll just give you an error when you compile and then you fix it, right? The other one's trickier because you don't realize it's being inherited privately and then you're confused, but you can't access variables properly. So anyways, you do that. And then you can just go ahead and you got to pick one for each. So I guess we'll do U for this one and T. It doesn't really matter at this point. They're just template variables. But that's pretty much it. So now, I guess if we compile it, it'll compile, but nothing will happen. But let's still make sure it compiles. Yeah, okay. So now let me go ahead and first of all, let me get rid of all these spaces so we have more space. And I guess I'll just work at the top of main. Okay, so yeah, let me add like an end line here as well. So let us go ahead and try this out by passing in add maybe like a 5 and then like a double or something, or yeah, let's do a double. Okay, so let us see if this actually multiplies, even though it's called add. Okay, let's see if it multiplies. 17. So I left it as an int, that's why I was like, that's weird. But yeah, so it did 5 times 3, 0.4, which would be 15 plus 1.2, which was 16.2, but it might have 17. 0.4 times, times 5, yeah. So 0.4 times 5 is actually 20. So yes, that would make 17 indeed. Yeah, okay, so that's actually correct. So, but you know, we gotta pick a return type for this. So I mean, we could always leave it as integer. That's fine. It work with templates, but you know, suppose we want to make it maybe return u, the u. So the left operand. So in this case, it'll still return actually 17. And maybe we make this also like 3.5, so that we actually have a fraction to see. So as you can see right now, it's still returning to us 17 because the answer is actually 17.5. But if we return instead the t, which that one's the one that's actually a double, then we'll actually get the double out of that, which is 17.5, as you can see there. We can no longer use strings in this template, right? No, yeah, I was gonna get to that next. So right now it will like be like, what the heck are you trying to do here? If you try to do something like, well, here, let me copy past this here. And then the second one is like a 5. So if I do that, you know, I'm gonna get yelled at that there's no match for this operator. And there's really not much I can do here because, I mean, yeah, no, there's not really much I can do here that I can think of. What I can do is if it was a class, like if it was an A, I don't have an A yet, but you know, if I did, then that one I can actually work with because I can, I thought I had a string there. Where did the string go? Oh, well, we can actually, yeah, sure, that's fine actually too. We'll still get the same thing. We'll still get the no match for operator time. We'll ignore this one for now. You can see no match for operator int and A. This one I can actually overload and get working. So like I can actually go ahead and, as a friend function, I have to overload it though. I don't think I can overload it as a member function because the left hand side is an int. So I could do something like int operator, friend operator, well, friend int operator plus const a ampersand r again. And then the function would be int operator plus const a ampersand r. Oh, not plus, but times, because I'm using times, right? And then here would be make an answer first, and then assign that to be, oh, I need the left side to this, so int a. And then here I need the left side, int ampersand. And then I get a plus, oh god, the variable name, so what am I doing? Okay, we'll call this I plus a dot r. Return a. Nope, return integer. So actually, if it's an integer that I'm returning, then do I want to return an integer? What do I want to return here? This is going to, I think we want to return an object of a. It doesn't really matter. You have to make a choice though. But I think this will be the easiest one. Okay. I feel unmotivated to do this. weird thing because I did so many weird things here. This would be a times. And then now that I did that, the operator overloading should take over. I am counting the second parameter, which is the A variable. So, but I'm returning a let's see, constant ax gets equals to I plus AR, return A, constant ampersand R, A operator int ampersand. Okay, so that's all right. So now I'm actually curious as to the why this is not working. So let me see what the error says. Class A has no member R. Class A has no member R. Of course it doesn't. Because there should be XR here. Or X here. What is the part AR in line? Yeah. So yeah, basically the same thing that the error said. And then the second thing is expected semicolon in line 10, in line 61 or 10, no 10. Yes, you are right. There had to be a semicolon there. And then no match for operator plus for some reason on that. Sure, I think it'll fix itself. Let me just try it again and see. No match for operator plus. Why is it calling the operator plus? 29, line 29. Who is calling that? And why are they calling that? No match for operator plus. Operand types are A and A. That must be coming from a different line or something. Because or maybe I broke my plus by accident. Yes, I did broke it. Damn it. So that's where the asterisk was at. I knew I put an asterisk, but I put it in the wrong spot. So that's what it was. Gosh, that's so annoying. Okay. All right. So all of that, so you can see that it works now, but now we are using two different types. We are using an integer, which you can't see there. Now you can see it. We're using an integer and we are using a class A. Here, let me see integer, class A, and it is calling this function, which just multiplies them. How do we know it works multiplication? Because we overloaded multiplication to basically make a new object and then take and fill that x with the left-hand side, which is just an integer, plus the right-hand side, which is an object of A. So we're accessing the x parameter of that object, which is an r.x, and that's what we're returning. So yes, that was a lot for that. So let's see what it says here. I have a question. Did you were going to bring the points that we have to accumulate for extra credit back? How it goes towards the semester? We can if you claim it the points now. You can claim the points now, but in your case, you got to claim it in the right class though, so that I can fill your points up. But you can claim it now if you filled enough points already. And yes, at the end of the semester, if you have like 10,000, like if you have 15,000 points, I will offer smaller tiers so that you can maximize your point usage. I just don't want to do that now because otherwise I'll have to like claim like 10 people every single day, which is kind of what was happening almost in the summer. So yes. Anyways, what is the A part? Yeah. So that was a mistake. So, okay, but anyways, as you can see, frankly, what we're having trouble with was the operator overloading. But the template stuff is really easy, as you saw. We basically just write that and just make sure that we are prepared to handle whatever the template is working with for any type that it passes. And if it doesn't, then it'll tell us. So yes, templates are not too bad yet. Okay. So let us move on to the other type of templates, which are class templates. what are class templates for? Well, you know, functions are great and all, but they have limitations, right? That global functions are not as great, especially, I mean, the whole point of this class is object-oriented programming. You want to use classes, right? And so, can we create a class that has a member variable? So, you know, right now we have our class A that has an int x in it, right? What if we wanted to make another class that had a float x? What about one that had a string x? What about that one that had another class A inside? Well, you wouldn't want to do that, but maybe it has a class B or some sort inside. Or maybe just a pointer or anything, right? So what if you wanted to have, you know, a class that can handle anything? You know, let's say that you want to have a class and inside it had an array. And that array could handle any type, whether it was strings, doubles, other objects, and so on. In fact, we already have played with that. You know, we played when we used a vector, right? Vectors are templates or are templated, right? Let's think back about when we were actually declaring a vector. How do you declare a vector? You write the word vector, you put the little brackets, surprise, and then you put in the type of what the vector contains. So like if you say int here, and then you say the vector's called like v, then this vector is basically an array of integers. And then you can use that one function, you know, b.pushback to insert things. You know, so like pushback 5. And then you can also like access that by saying b0 and then like couting that. You know, and you can do this stuff, right? Guess what? This is implemented using templates. And we're about to see that right now. We're gonna make our own fake vector class. Maybe not today, because that might take a while, but next time, since we technically have the full week to talk about templates. So, yeah. So essentially, what we want to do is we want to be able to create a class that has some variable that is again templated, and it's only going to be defined when you decide what you want it to be. So if you want to make, we want to make our class A with an int x, but then we want to make a class A with a float x, we're going to define that again at compile time. So this is all happening at compile time, not at runtime. Okay, so let's go. Let me go ahead and give you the syntax for this. The syntax for it is the same almost as the function one. So you still write the word template and the whole class A or whatever, class T. We'll stick with class T. And then you just write your class declaration like normal. And that's pretty much it. You're done. So let me go ahead and give you the example with the class A that we work with. So you write the word template, class T, and then class A, curly bracket, and then we are going to make our template a variable. We can make more than one, by the way, but I'm just going to put one. And by one, more than one, I mean more than one of the same type. If you want to have multiple types, like we were doing just a second ago with the functions, you can do that as well here. Again, that would be class T, class U. We'll do that in a bit. Let's stick to just one for now. And then I guess I'll put an example of a function that you can use with this. So you can still use your template functions inside of it now. So you could do something like template T ampersand G. Okay? And that would mean that you have a function that is called foo that actually deals with this template. Okay? Maybe I'll do one inline function and then one not inline function so that you can see how that is kind of done. So here, push this back further down. So let's make two functions. Let's make a foo and let's make a bar function. So let's say the bar function is just a void function that's inside of the class. Maybe it just calls a cout. Yeah, in fact, yeah, we should have called it print, but whatever. So, but let's say it still takes a parameter just so you can see it. Okay? So it takes another parameter like that. And then let's just say this like cout G plus A. A being our local variable or class variable, sorry. Huh, sounds like GTA, but it's G plus A. Okay, so essentially what we've done is we've created a template class. Let me close it with a semicolon right there. We created a template class called A that has a variable. So this is kind of, in fact, if instead of A, you know, let's call it X, because we were calling it X in the example earlier, int X. So it says TX. And we created a random function bar that takes another of the same type as X and just adds them together and then see outcome. Now, of course, for this to work, X has to be some built-in data type. Otherwise, you'd have to overload X itself, okay? But, you know, that's where actually templates start getting nasty. But not yet, okay? So the last thing is, I'm going to show you how to declare outside of the class a function. So we have the foo function that we have not declared, right? So let's go ahead and actually do that. To declare a template function outside of the class, you have to manually write the word again, template, you know, class, T, and then it's a value returning function. It's a T returning function, so you have to write the word T for the return value. And then this is where it gets a little interesting. So normally you would write something like this if it was a normal function, A and then foo, right? That's how you would normally do it. G plus X. Yes, I'm just adding two random things because why not? Just whatever this parameter is plus the class variable there. So G plus X. Okay? So anyways, in this case, this will not work with a template. You have to modify it slightly. You have to put in as a return type the type. Sorry. You have to put in along with the class name any template variables that it has. So this actually becomes a T like that, and then you put your colons, and then it'll work okay. So it's a little bit strange, but you have to get used to that. And then foo also had a parameter in it. Oops. And then you can go ahead and write your code. So this function, let's just say that it, you know, returns G++. Okay? Write that nicer. G++, like that. Okay? So that's just, as long as G is some type that's built in, that works. Otherwise, again, we'd have to overload the operator, right? This is the post increment operator that we'd have to overload. That's pretty much it. Trying to see if I have other examples of other things to do here. Oh, I have this little syntax. Might be useful, so I'm going to copy and paste it from my notes. These are from the summer notes, actually, that I'm looking at. It's kind of like a reminder of how to do this. So, as a reminder, you write the word template, you put class type, and then you put in the return type, as you can see there. You put the class name, you put the less than T, greater than T, colons, the function name, the parameter list, and then you put your body of your function. Okay? So, yeah. And this will be the compared to the non-templated version, which is the bottom one. So I'm going to get rid of that because I don't want to confuse it. But yeah, so that's a good little like thing to have next to you. This is how you define a function outside of a class that is templated. You know, that it belongs to the class. So it's a member, you know, member function. So again, you're going to put the word template. You put in the return type, the class name. So let's see how those match with this. Template class T, that matches identical, I suppose. Return type in this case is a T, but it could be an integer, float, whatever. Class name is just an A, less than T, greater than T, that's just always like that. Your scope resolution operator, function name, which in this case is foo, and your parameter list, which can be empty, but more than likely has at least one parameter. In our case, we had one that we were passing by reference called G, that is of T type, which again is a template type. So, yes. Why is that becoming dark? All right, there we go. It was like my thing was going into like screensaver mode. All right. So that is pretty much it. Now, vector int ampersand vector foo g plus you put in colon. Is that for std? No, the colon is because foo belongs to class A, because it's part of the class declaration and definition. So that's why I'm putting it. The two colons together, the 4 dots, is called the scope resolution operator, and it has 2 main usages, which is the same thing, but 2 things. You put it to specify that a certain variable or function belongs to a certain class. So in this case, we're saying foo belongs to class A. Alternatively, you can use it to define a namespace, which we don't really talk about in 135 or 202. But if you don't put it on the top of your programs using namespace std, then yes, you would have to actually put std : like cout, because that is where cout actually belongs, that namespace. So that's why you see sometimes in code things like std : cout, like hi. That is because they are not using the using namespace std at the top. And you can make your own namespace too. Just I'll try to put a description on the YouTube video to a link in Geeks for Geeks that talks about namespaces. But it's kind of like it's one of those things that we don't really cover. I mean, there's so much. The language is massive. There's not enough time to cover everything. And this is one of those things that you don't really need to know. But yes, that is why on top of every single program that you write, we have to put this. And I'm sure some of you have forgotten to put it at some point, and you get these weird errors that claim that cout does not exist, and then you fix it by putting that in. That's kind of that. So yeah. Okay, I'm gonna start out fresh for the class one because it's too big. So we're gonna go ahead and make a templated class, and we're gonna jump right up into like a 2 variable example, because you kind of already saw 1 variable. Okay, I guess. So what we're gonna do is we're gonna start trying, actually, well, no, I'll make a very simple one, and I'll do the vector one next time, because yeah, the vector one, there's no way you can finish, and I'd rather just do a whole example. Okay, so we're gonna call this again class A, because originality, I don't know. And then we have 2 templates, so let's just make, 2 variables that have each of those templates, I suppose. Like that. Why not? Let's make a simple constructor, because you always think, we'll probably have one. So in the constructor, we have to be careful, because we don't want to do something like this. We don't want to say like x equals 0, because then we're already assuming that x is some sort of numerical data type, when it might not be. It could be a string, or it could be a class, and things will get messy. So really, there's not much to initialize here. Maybe, I know what we can do. Let's make one of these dynamic. So one of them's a pointer. So what I want to do is we're going to initialize it. So we can say like y gets new, and then what? Normally you put like int, double, string. What do? We just use a t for type. At compile time, it'll figure it out, what it needs to be for that. Okay? And I suppose since we added a constructor that has something dynamic, we probably want to add a destructor to avoid memory leaks, where we say delete y. You say y gets null afterwards. Doesn't have to, but you can do that. I suppose since we do that, rule of 3 says that we have to overload the assignment operator. So I guess we'll do that really fast. So the assignment operator, oh gosh. Let's not do that. That's going to take too much time. Yeah, we can do that at the end if we have time. All right. We just don't do any assignments. We won't do things like class A equals to class B or something, or copy constructor. What we can do is we can do the copy constructor really fast, actually. So that one we can do. So we'll say something like y gets new t, and then dereference y gets r dot y dereferenced, like that. Okay, so that would be a good copy constructor. We don't have an assignment operator, but I would rather really not do that right now. I want to run into bugs and spend some time fixing them. So, okay. So let's just make sure that this well, that I always forget. Let's make sure this compiles. Is it not called temp2 CPP? Okay, G++. Temp. No, it's called temp. For templates, by the way. I don't think we need the std equals 2 plus 11. Okay, cool. It's working. And now we got it set up. All right. So let's go ahead and make an object of this class. So here's the thing. Here's the trick. That's not going to work. That's going to give us an error. Well, why is that? Why it keeps adding this? I don't know. Here we go. I reset it to the first one. There we go. Okay. So you can see missing template arguments. So when you have a template class and you try to make an object of that class, so in other words, you want to instantiate that class, it's going to give you an error. So what do we need to do for that? Well, when you want to make a class, you need to put in the class name, less than sign, greater than sign, the template types, and then the identifier. So in the example of our class A, we'd have to do something like this. A int A, or like A string B, and so on. So whenever you are declaring an object of a templated class, you need to specify what the types of the template need to resolve to. This is why you're able to check this at compile time, because you're telling it at the time of creation, like, hey, those template variables that you've made, they're great and all, but in this scenario, I need them to be integers and floats, or I need them to be strings and doubles, or I need them to be other objects, right? And that's it. We have to, no. Your terminal is trolling you. Yes, it is trolling me. We don't have to include the colons in this case for the declaration. And by the way, you've seen this before. Every time we declare a vector, right? Go back to the example. Where's my vector thing? Now it actually finally appeared in the right spot, right? So as you can see there, you got, when you declare a vector, you write the word vector, which happens to be the name of the class. You specify the type of the template variable, and then you go ahead and list some identifiers. So every time that you're declaring vectors, and I told you, you just gotta put these signs and just accept it as fact of life. Now you know why. Now you can say as to the why that syntax is like that, because it's a template syntax, right? So you've been using templates probably since 135, and you just didn't really know about it, or we were told just like don't worry about it, just accept it, right? So that's pretty much where that syntax comes from. So now you know. Now we're, like I said, we're making our own vector classes pretty soon. I don't know what you mean with the colons. You don't need to declare colons with this. You just put semicolons. That's only when you're making like a member function or something. So anyways, in this case though, we need two of them technically. So what do we want to make for them? Let's just make them integers first. I guess technically you could actually make them both be the same, by the way. Even though you've used different template variables, you can do that. But you can also make them different. So like, let's make this one a double. I'm sticking to built-in data types so I don't have to overload things. But, I could, if I wanted to do, I could do like not built-in data types. But anyways, if you do that, it works fine. Now, if you do things like an A instead of an A, yeah, this will actually work, I think. Like, however, this A needs its own set of templates. So, something like that you could do. I think that'll work. Yeah. This is where templates start to get kind of weird and nasty. But I mean, you know, I'm going to make a video about it in more detail that I made over the weekend. It wasn't actually over the weekend. It was one evening that I was bored, and I made that Creepio assignment that I posted a video on Discord, and it's now on my YouTube. It's a teaser for an extra credit assignment that I've made for both classes, 202 and 302. And I was part of the assignment is making a 3-dimensional array, and I chose to do it vectors. And it's nasty. Like you gotta be very careful how you do this. So like that's a 1-dimensional vector. So if you make a 2-dimensional vector, you know, you make it something like this. I think I use car pointers. So that would be a 2-dimensional vector right there. And then I think a 3-dimensional vector, which is what I ended up using, was essentially writing here vector again and doing that. I think that's what I did it. I spent maybe like 5 hours in the assignment, but it wasn't like 5 hours of non-stop coding. I went to eat in the process and like watch more Creepio parody. But yeah, I think I screwed that up already. But anyways, it's something like that. I can't remember. But hey, I got it working, which is what counts. So should be within the nested template argument. Okay, I think it's saying I actually have to add spaces. Okay, that's the weirdest compiler error. I did not see that when I was coding it the other day. But yeah, there you go. I think this is actually a 3-dimensional vector right there. So and apparently you have to do that, which I don't remember doing that. But yeah, okay. Oh, that's what the is for vectors. That is the same thing as the cast functions using. Yes. That has a lot to do with that. Yes. So the cast functions, I'm very glad you actually brought that up because I would not have remembered. So if you do something like that, yes, that is also vector related. The casting thing is like using vectors to do that. So yes. But anyways, as you can see, not just this, but the vector one works too. So I know we didn't really do much with it, but as you can see, we created objects of the same class, but each class has its own different data types, right? This is like U and T are integers. This one's just an integer. This one's an integer pointer. I guess it's the last thing because we're out of time. You know, suppose I wanted to see out the contents of it. So let me first put things in it. So like X, I can put in like a 5, and Y is a pointer, so I have to use the dereference operator to put in like a 6. And then let me see out AX plus A dot Y. And then this should equal 11, I hope. As you can see there, okay? So we'll play more around with this, and maybe what I'll do next time is I will make a really cool as a point of view. I'll make a nice vector class, we'll make our own vector class essentially, okay? So now you won't have to ever use vectors again. You can use your own vector. No, it's not going to be as cool because vectors have like 50 functions in them. You know, you can see that by doing like v dot and then look at all those functions. You know, a lot of them make sense when you look at them, but some of them are like really fancy and you have to like do stuff. So we won't make it as fancy, but we'll make the basics. We'll make the push fact function and make it like an erase function or something and whatnot. So yeah, but I'm glad you actually brought up the idea that static cast, because yes, the static cast stuff and dynamic cast and reinterpret cast, I suppose, does the fact that you put that there is it is vector related. So yeah. Today I gave you a brief overview of how vectors work at the basic level. Sorry, vectors work. Templates work. I mean, vectors too, I guess, now, because now you know it's templated. But yeah, next time will be about just doing all examples, because I have the whole week allocated to templates. So yeah, we'll do the big vector example, and maybe we'll do some inheritance with templates as well, because that's where things get a little bit nasty. And it's nasty is by syntax. The syntax gets a little bit weird. Like, and by weird again, I mean like this kind of stuff. Like this to me is kind of weird. I mean, the fact that I had to put a space there is just a weird thing. But that's what people kind of grumble about with templates. That you have to do weird things like that. Like you have to put a space there because otherwise the compiler complains, but it complains exactly knowing what you were trying to do and telling you. It's like I know what you're doing, I could have done it for you, but no, I'm going to say no, and I'm going to make you put space there. I'm like, but you knew what I was doing. Why didn't you just take it? It's like, no, I will not take it unless you put those spaces there. It's like, okay, yes, master. You know, do not question the Darth Sidious compiler. So, yes. All right. So, with that, I shall end the lecture, and we shall continue on Wednesday. Okay? Thank you all for coming. I'm very happy that I had people talking. And as you can see, you actually helped me out to fix some of the errors. So I'm very grateful for that. Otherwise, I would probably still be trying to fix some of those. So I'm glad. Okay? Well, in that case, I shall see you all Wednesday. Have a good week. And I suppose the class schedule is available now. So you can see the class times for next semester. Pretty much all the CS classes, at least the lower level CS classes, say staff, and nobody knows who's teaching what, so don't ask me. I don't even know what I'm teaching, but definitely start looking at that, because you don't want to get screwed over with your schedule. So you want to sign up the first day possible. I have no idea how it's going to work with the remote stuff, but even if it doesn't, you want to make sure you get a good schedule in, ahead of time. So definitely check that out. Yeah, yes you can. It actually opened up today. That's why I'm announcing it now, because like somebody told me on Discord, and I actually went in there and like I saw it. Like here, I can try and show you. Like I don't have to log in into like my account or anything. Like it literally just pops up if you go here. Ah shoot, it's like auto-filling my password. Hold on. How do I? Well, here, let me erase it by hand. There we go. Okay, so push this over here. See, that's like my UNLV login portal. I don't even have to log in. I can just click class search, and it already shows me spring 21. Put CS, I put 1 greater than or equal to. And there you go, all the classes. I'm surprised that most of the classes have like rooms in them. I don't know if that's going to stay like that. I'm assuming that they're going to make it like last semester, where they'll give the option to the instructors to switch to the remote. So yeah, but anyways, still, like, do not wait. Enroll the first second, otherwise you're going to miss out on your classes. Yeah, I don't know. They keep changing that like every day. So I agree with you. Like it used to be red and now it's like bluish. I like this login better. It's more friendly. The other one was like very old school looking. So yeah. No, yeah, I think they added it like literally today, like this morning. So like I just ran it like an hour before class started. So I saw it, I was like, oh cool. And then I was like, okay, now I gotta teach class. So anyways, I shall let you guys go then. But yeah, check that out. Again, I don't know what I'm teaching, so I have no clue. But I hopefully find out soon too. So I'll see you guys next time. And stay safe. See ya.